A and B are two sets of traffic lights on a road. The probability that a car is stopped by light A is 0.4. If a car is stopped by light A, then the probability that the car is not stopped by light B is 0.7. If the car is not stopped by lights A, then the probability that the car is not stopped by B is 0.2. So we need to complete the probability tree diagram for this information. Okay, so that's a lot of information there, so we're going to break it down. And luckily they've given us this tree diagram here already to help us. So here we've got our information for lights A, and here for lights B. So we're going to go through the question line by line. So probability that a car is stopped by lights A is 0.4. Okay, so on the tree diagram, we've got lights A here, and here's stop. So here's where we're going to put the probability. So the probability that the car is stopped by lights A is 0.4. So that goes on this branch of the tree. Okay, so next line. If a car is stopped by lights A, then the probability that the car is not stopped by B is 0.7. So the car's been stopped by lights A, so we've gone down this part of the tree, and then it's not stopped by lights B. So we then go down this part of the tree to not stopped. So we're going to be putting our probability here. And in the question we're told that's 0.7, so I'm going to put that in here. So you've done that one now. So if a car is not stopped by lights A, so we're going down this path, then the probability the car is not stopped by B is 0.2. So we've gone down this path, and then it's not stopped by B either, so we've gone down this path. So we're going to put our probability here, and that's going to be 0.2 as it says in the question. Great, so we've got all our information from the questions. So now we need to work out these three other probabilities. So I've written here that the sum of probabilities is 1. And what I mean by that, so I'm going to have an example here, is that the probability of either getting stopped by lights A or not stopped by lights A is 1. So that's definitely going to happen. You're either going to get stopped by lights A or not stopped by lights A. There's no other option. So there's a 100% chance of one of these things happening. Therefore, these probabilities need to add up to 1. So to work this out, we're going to do 1 minus 0.4, which gives us 0.6. So in here, we're going to put 0.6. Now it's the exact same logic over here. So look at this part here. Again, the probability of being stopped or not stopped is going to happen. One of those, they're the only two options. So they're going to have to add up to 1. So we've got 0.7. So it's going to be 1 minus 0.7, which equals 0.3. Just going to put that in there. And the same thing for here. Both the probabilities are going to add up to 1. So you've got 1 minus 0.2, which equals 0.8. It's going to pop that in here. Fab, so we're all done with part A. And we get 1 mark for correctly putting all the answers in light A. And we get 1 mark for correctly putting all the answers in lights B. So now moving on to the next part. Mark drove along this road. He was stopped by just one of the sets of traffic lights. Is it more likely that he was stopped by lights A or lights B? You must show your working. So the key here is he was stopped by just one set of traffic lights. So we're going to look at the diagram to see what the possibilities are. So he could have been stopped by light A, but then he can't have been stopped by light B. He's going to have to be stopped by light A and not stopped by light B. Or he was not stopped by light A, but then he was stopped by light B. So there are these two possibilities. This route through the tree, or this route through the tree. Now I've just written this thing down here saying for and we multiply. And hopefully you'll see what I mean in a minute with that. So we're going to look at the two options. We've got the probability of being stopped by lights A and not stopped by lights B equals. So we've got the probability of being stopped by lights A, which is 0.4. And this is the key here, it's and. And here I said we use multiply for and. So essentially what that means is we're going to multiply the probabilities together. We've got the probability of being stopped by lights A and the probability of not being stopped by lights B, which is 0.7. So we're going to multiply 0.7. So working that out in the calculator, we get 0.28. So that's our probability for that option. So now we've got the second option. We've got the probability not stopped by lights A and stopped by lights B. So again, we've got our and in there, so we're going to be using multiplication. We're going to have a look at the probabilities. So we've got not stopped by A, so that's 0.6, and stopped by B, so that's 0.8. So we've got 0.6 multiplied by 0.8, which gives us 0.48. Great, so we've now evaluated both our options. So now we've got to answer the question, is it more likely that he was stopped by lights A or lights B? Well, for the first option, he was stopped by lights A, and for the second option, he was stopped by lights B. And the probability for the second option is 0.48 is greater than the probability of the first option, 0.28. So being stopped by lights B is more likely. So in this part of the question, we get 1 mark here for multiplying our probabilities together. We got a second mark for getting the correct results here. We got a third mark for a correct conclusion by comparing the probabilities.